Okay, today we're going to be doing a new topic, topic number 6, parallel lines and transversals. This is the topic that we covered on Friday. Before we actually get into it, though, and remember, always go ahead and press pause on the video to go ahead and copy down what you need to copy down. The notes for today are going to look like this. Tomorrow's notes are going to look like this, just so you have an idea of what it is that we're shooting for. But again, today we're only going to worry about topics 1 through 5. Before we actually get into this, we're going to go ahead and talk about what parallel lines are. Parallel lines are two lines that will run right next to each other and they never intersect. So these would be parallel lines. And they would denote parallel lines by either using like these single arrows or maybe even like a double arrow, letting you know, like, oh, these two lines are parallel to each other. Okay, so that's what parallel lines are. Two lines, in this case, these two that don't intersect. And we're also going to be talking about transversals. Transversals are lines that actually do cross through two other lines. All right, so a transversal would be that line L over there. So, yeah, parallel lines, two lines that don't intersect. A transversal is a line that crosses over two lines. We're going to go ahead and go over the first theorem. The first theorem is corresponding angles are angles that occupy the same relative spot. These angles are congruent. That means they are equal to each other. So I'm going to go ahead and highlight corresponding angles. And I know that corresponding angles are congruent. What does that mean that they are the same relative spot? Well, if I take my highlighter and I focus in on this angle 1 right here. First of all, before we even start that, notice that I have two parallel lines that's being cut by a transversal. All of the stuff that we covered today is going to be under those assumptions, okay, that you have parallel lines being cut by a transversal. So if I look at angle 1 and I were to describe it as it relates to angles 1, 2, 3, and 4, I would say angle 1 is on the top and on the left. So angle 1 is on the top left. If I were to try to match that up with the angles down here, 5, 6, 7, and 8, what is the angle that kind of has the same spot, right? So which one of the 5, 6, 7, or 8 is also on the top left? Well, if I look at these ones on the top and on the left side, would be that angle 5. So I would say angle 1 is corresponding to angle 5. They're in the same relative spot if I were to kind of slide those angles down that line. Because they are corresponding angles, I can say that angle 1 is congruent to angle 5, which means if I know that angle 1 is 103.7 degrees, then I know that angle 5 is also 103.7 degrees. They have to match up exactly. All right. That's not the only example of corresponding angles. Like we can go ahead and take a look at angle 2. If I were to focus on angle 2, I would say angle 2 is on the top right. And out of these ones down here, the one that's on the top right would be angle 6. Since angle 6 corresponds to angle 2, then I can say that angle 2 is congruent to angle 6. Guys, another quick check to verify is knowing whether the angle is acute or obtuse. So, for example, angle 1 Angle 1 is an obtuse angle. Look how open it is. It's definitely pretty open. And that matches up with angle 5, which is also obtuse. So I have an obtuse angle with an obtuse angle, and it makes sense that those would be congruent. Same reasoning, if I take a look at angle 2 is an acute angle. It's definitely a lot more closed. And so is angle 6, also acute. So it would make sense that angle 2 would be congruent to angle 6. Okay. If I wanted to match up my last ones, let's see. If I take a look at angle 4, angle 4 I'm going to denote with like this open highlighting. Angle 4 is on the bottom left. And if I were to match that up on the other side, it would match up with angle 8. So I can say that angle 4 is congruent to angle 8. And obviously I can match up angle 3 is on the bottom right. And angle 7 is also on the bottom right. So I would say that angle 3 is corresponding to angle 7. Therefore, they are congruent. Okay, as far as corresponding angles are concerned, that's pretty much it. Some students like to use this trick. So with your highlighter, if you can do me a favor and draw a slanted F, make sure you're doing this with your highlighter. There's kind of like a little trick where it's kind of easy to find some of these corresponding angles by using a slanted F. What do I mean by that? Well, let's use the parallel lines to start creating these slanted Fs like this. And the angles that it catches, this angle and this angle, are corresponding. You can also do backwards Fs. For example, if I did my backwards F like this, The angles that it catches, angles 4 and angle 8 would be corresponding. I could do upside down Fs. And the angles that they catch, angle 6 and angle 2 are corresponding. I can do upside down backwards Fs. And the angles that it catches, angle 1 and angle 5 are corresponding, okay? It's just a little trick to see where the correspondings are at. I'm going to say, look, do you see any Fs? And that's what I mean is trying to make Fs out of the parallel lines and then see what angles they catch. We know that those angles are going to be congruent. Okay, a bit of vocabulary before we move on for today and for the rest of the semester, I guess. When I say interior, and I'm talking about parallel lines, then I'm talking about the angles inside the parallel lines. Interior means inside. So interior would be the angles inside the parallel lines. When I say parallel lines, you can denote parallel by using 2 forward slashes, using that symbol right there, the forward slash, forward slash. I'm going to be using that shortcut a lot instead of writing parallel, so you should get used to it. So if interior is inside the parallel lines, then that means exterior would be outside the parallel lines, which we denote with forward slash, forward slash. An alternate, in our case, is going to be like the opposite, like to alternate or to switch over would be to go over to the opposite side, okay? So when I say alternate, I mean opposite side of the transversal. And again, these vocabulary words will make more sense once we start doing examples 2, 3, 4, and 5. And then obviously same side would mean, hey, don't go on the opposite side. You got to stay on the same side of the transversal. Don't switch over to the other side. So there's our vocabulary words for now. We're going to go ahead and start hitting up these 4 more theorems. Let's, again, go ahead and pause the video and copy down what you need to copy down. I'm going to assume you already did that. So let's go ahead and talk about alternate interior angles. I'm going to go ahead and highlight that word, alternate interior. Alternate interior angles, they're telling me are congruent. I'm going to focus with that second word, which is the interior. Remember, we said interior means inside the parallel lines. I'm only going to focus on the angles inside the parallel lines. So here are my parallel lines. I know they're parallel because I have this symbol here. I want the angles inside the parallel lines, which means I want the angles in between right here. I don't want the angles on the top and I don't want angles on the bottom. So if you can do me a favor and highlight the stuff in between, but do it with a light highlighter color because it will bleed through. Try to pick your lightest color and don't go super dark on it, okay? Try to keep it light. So we're only looking at the interior angles, which means we're only looking at angles 3, 4, 5, and 6. Let's go ahead and focus in on angle 3. I want to find its partner, but I want to find its alternate interior partner, which means, again, I'm only focusing on the inside angles because it says interior, and I want to alternate. And if I want to alternate, if I go back to my vocabulary words, we said alternate means to be on the opposite side of the transversal. Here's my red transversal. Here's the angle. I need to alternate sides, which means not only do I need to switch over, like hop over that line, but I want to hop over all the way, which means I'm going to go all the way down to angle 6. I'm not going to focus on angle 8 because angle 8 is exterior, right? I only want the interior one, so I'm going to focus in on angle 6. Angle 3 is congruent to angle 6 because they are alternate interior angles. They're both on the inside and they're on complete opposite sides of that transversal, okay? That's if I focus on angle 3. If I were to focus on angle 4, we could do the same thing. Here's angle 4. I want the alternate interior angle. Well, angle 4 is definitely on the interior, but I need to alternate, which means I need to hop over that transversal, which means not only do I hop over here, but I want to go all the way on the opposite side, which means I'm going to go ahead and go all the way to angle 5. That means I'm going to highlight angle 4 and angle 5 as partners. Angle 4 and angle 5 are alternate interior angles, which means angle 4 is congruent to angle 5. For alternate interior angles, we do have a a letter that kind of helps us find them. In this case, with your highlighter, I want you to make a letter Z. For alternate interior angles, we're going to look for that letter Z. Okay. What do I mean by that? Well, look, check this out. You can make forward Z's, you can make backward Z's, you can make flat Z's, you can make short Z's. So let's look at this backward Z right here. I'm going to use my parallel lines, make my Z. And the angles I catch, angle 4 and angle 5, are going to be alternate interior angles. Okay. I can also make a regular Z, but it's going to be really, really flat. I know you're going to look at it and you're going to be like, it's not a Z. It is a Z. It's just flat. So there's your really, really flat Z. And what angles does it catch? It catches angle 3. It catches angle 6. So therefore, they are alternate interior angles. Okay, so we got those set. Let's take a look at the next one. I want alternate exterior angles. Let me go ahead and highlight those words. Alternate exterior angles. This theorem says those angles are going to be congruent. I'm going to focus on that last word, which is exterior. Exterior means outside of the parallel lines. So when I focus on my parallel lines, here are my parallel lines. I don't want the stuff inside. I want the stuff on the outside. So I'm going to highlight these sides out here. Again, with a really light colored marker, let's go ahead and highlight the top. And let's go ahead and highlight the bottom. That means I'm only going to be focusing in on angles 1, 2, 7, and 8. Let's go ahead and focus in on angle 1 and try to find its partner. Here's angle 1. Again, I need to be on alternate sides. So here is my transversal. Here's angle 1. I need to alternate, which means I need to flip over side. But not only do I need to flip over that side, I want to go on the complete opposite side, which means I'm going to match up with angle 8. Angle 1 and angle 8 are alternate exterior angles. And since they are alternate exterior angles, this theorem says that they are congruent. So I can say that angle 1 is congruent to angle 8. As a check, guys, like, look, this little angle right here, that is definitely an acute angle because it's very closed. It's not open. And if I look at angle 8, it's also acute. Angle 1 and angle 8 are acute, so that makes sense that they would be equal in measure, okay? And you're going to see later on when you go, wait a minute, that can't be right, all right? Let's take a look at another angle. Let's say if I were to look at angle 2, and I want to find its alternate exterior angle. Here's angle 2. That's an exterior angle because it's on the outside, but I want the alternate angle, which means I need to flip over that transversal. So here we go. I'm going to hop over the line. Not only do I want to go on the opposite side, but like way on the opposite side, which means it's going to match up with angle 7. If you look at angle 2 is an obtuse angle. It is very open. And if I look at angle 7, it is an obtuse angle. It is very open. So since they are both obtuse, it would make sense that those angles are congruent. Angle 2 is congruent to angle 7 because they're both obtuse angles and they're alternate exterior angles. Unfortunately, guys, for alternate exterior angles, there is no like tricky letter that you get to use to go find them. Like there are no F's and there are no Z's, okay? You're just going to have to kind of match them up, go by the definition. All right, we got 2 more examples. I got same side interior angles are supplementary. So let's go ahead and focus on the vocabulary. Let's see. I want same side interior. I'm going to focus on the last word of that, which is interior, means inside the parallel lines. So I'm going to take my light highlighter and I'm only going to look at the angles on the inside, which means I'm only going to focus on angles 3, 4, 5, and 6. And I want to go on the same side. So let's see, let's focus in on an angle. Let's focus in on angle 3. Here's angle 3. I need to stay on the same side of that transversal. So here's my angle, here's my transversal. I need to stay on the same side, which means I can't flip over. I got to stay on this side. I can't cross that red line. So that means when I hop over here, we must be talking about angle 5. Okay. Here's where it gets interesting. When I look at angle 3 is this one right here. Look how open that angle is. This angle is obtuse. Take a look at angle 5. That angle is very closed. It is not that open. This angle is acute. So if you're telling me angle 3 is obtuse and angle 5 is acute, I don't want you telling me that they are congruent. There's no way. One of them is way open and the other one is way closed. There's no way they measure the same amount. And that's not what our theorem says. In fact, our theorem says they are not congruent. They are actually supplementary. If you remember your vocabulary, supplementary means these angles are going to add up to 180 degrees. So I get to write angle 3 plus angle 5 equals 180. Please don't tell me that they are equal. They are absolutely not equal. They're supplementary. They're going to add up to 180. And you can just kind of visually tell, like, hey, those angles are not the same, right? Okay, so that takes care of those. Let's take a look at angle 4 and find its partner. I'm pretty sure you already know what it is, but let's just go ahead and go through the definition, go through the whole process. Here's angle 4. There, it's in the interior, and I want to be on the same side of this transversal, which means I can't flip over to the other side, which means I got to go this way, and it's got to match up with angle 6. We're going to go through that same process again, but we're going to do it a little bit quicker. Angle 4 is an acute angle. Angle 6 is very open, so it's obtuse. If the first one's acute and the second one is obtuse, there's no way they are equal, so they are not congruent, because again, the theorem says that they're going to be supplementary. So I get to write that angle 4 plus angle 6 is going to equal 180 degrees. Now that I have that laid out, now I can go ahead and see, well, is there any shortcuts? There are shortcuts, guys. For this one, for same side interior, you can look for like those really solid letter C's like this. You see how I kind of made them all jagged? We're going to look for C's. So here is a C with my parallel lines, bam, 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 and the angles that it catches, this one and this one, will be same side interior angles, which is going to make it supplementary. I can also make a backward C, bam, bam, and bam. The angles that it catches are going to be same side interior angles, which are going to be supplementary, which means they're going to add up to 180. All right, we got one more and we're done with the notes for today. We're going to go same side exterior. We're going to go a little bit quick. Same side exterior. Let's see. We're going to highlight the vocabulary words. That's this one. I'm going to focus in on that second vocabulary word, which is exterior. Exterior means on the outside of the parallel lines. So I'm only going to focus up here and down here, not on the angles in between. So I'm only talking about angle 1, 2, 7, and 8. Let's go ahead and focus in on angle 1. Here's angle 1. I want to find its partner. Here's angle 1. It says same side exterior, which means I need to stay on the same side of this red line. I can't hop over, so I must be talking about angle 7. Angle 1 is an acute angle. Angle 7 is an obtuse angle. Since they are not the same, then I cannot write that they are congruent. In fact, they are supplementary. So I'm going to highlight this in a different color just so it stands out. And I get to write that angle 1 plus angle 7 must add up to 80 degrees. They are not congruent. And if I did the exact same thing, I would look for angle 2, try to find its partner. Angle 2 is up here. I want to stay on the same side of that transversal, which means I can't cross over. Boom, boom, boom. That means I must be talking about angle 8. Angle 2 is acute. Angle 8 is obtuse. They are definitely not equal. So I get to write angle 2 plus angle 8 is equal to 180. They're going to end up being supplementary. Okay. I just realized I didn't put degrees on any of these things, and we really should have those. Okay, there's no shortcuts for this one. There's nothing to look out for, no special letters. Hopefully that process made sense to you. I will say that it's a lot of vocabulary, and if you can stay with the vocabulary, we should be good. All right. Hopefully that helped, and if you have any questions, as always, feel free to ask me.